It's recording, Shelps.
Oh, I'm ready to learn.
Okay, so vector, this, I say it's an introduction, you've learned some stuff at GCSE. So vectors have both magnitude and direction, so the direction that something goes is important, okay? This vector starts here, starts here, and then ends up here. It's got a baby arrow on it. It's as big as I can make it. I'm sorry, it's not bigger. This vector happens to go across 2 and up 3. So this vector would be this. So the top number tells you you're across, and the bottom number tells you you're up, down. Okay? Who's whispering?
I said just the run of the ride. Well, it's just the ride.
Yeah, so I would probably avoid using those words just because it's going to confuse you when it comes to gradient. So horizontal and then up, down. Okay, so this B is the same one, so it goes across 2 and up 3. So these are exactly the same. This C, however, starts here and ends up down here. So this is left 2 and down 3. So whilst the actual line itself looks exactly the same, it's actually a different vector because it goes the opposite direction.
It's negative 3 over negative 2.
So it'll be negative 3, negative 2, yeah. Okay, now, you may think, well, why has it got a little line underneath? So it tends to be that we will write vectors with a squiggly line. I can't do that on Smart, so it's just an underline. And the reason is because normally they're shown bold, but we can't do bold when you're writing. So you show that it's a bold by doing the little underneath.
Are A and B different?
No, A and B are the same. Okay? Now the modulus is the length of it, the magnitude. That's stuff that you would have done at GCSE. And we use Pythagoras' theorem to find the modulus. Okay? The nice thing is the modulus will always be the hypotenuse. So it's always going to be the two numbers squared and added together. So you're not going to have to decide, is it plus or is it minus? It's always going to be plus because you're always finding the hypotenuse. Okay, so the modulus is shown with the two lines on either side. Okay, we've used that word before. So it's the size of it, the modulus. And you're going to use Pythagoras to do that. A scalar multiple of a vector is a vector in the same direction, but with a different magnitude. So if you can, so for example, A plus 2, oh no, I'm saying it differently now. What's Harrison? So if I had 2, 3, and I had 8, 12, okay, these two could be written, so this one here I could say was secretly 4 lots of 2, 3. Yeah, you agree with that? What are you whispering about?
Just if you sound like Mickey Mouse.
I thought it that.
You look like Mickey Mouse.
It's only just started since I've come here.
I thought that.
It's only just started since at lunchtime. Shut up. Alright, so can we see that 8, 4 can be written as 4 lots of 2, 3?
Mm-hmm.
Yes? So they would be scalar multiples of each other? Yes? So it would also mean that they would be parallel to each other because we can do that.
I thought it was funny.
Alright, okay, so if we want to describe... Oh, shush now. Okay, so here they've said big A, big C. Now the line on the top, the arrow on the top, tells us that they want us to start at big letter A and end up at big letter C. Yeah, so if you see that kind of terminology, that's what that means. So we're starting here and ending up here. Now sometimes, whilst you can say, well, that's really easy, we just do that. But sometimes we have to follow a different path. So if we've been told that from A to B is called the vector P, and from B to C is called the vector Q, then we could also say that big A to big C could be P plus Q. Do you follow that? Jennifer's face. Yes? So they've said that this is vector P.
Gets to the same place.
Yeah.
If you take Harbor Road and take Middle Road, you're still going to get to wherever your destination is. Just depends on
One
where
is
you
longer than. You might have to take two roads.
So
So like A, B, C,
if
it takes
it's-
longer than A to C.
get. Yeah. To go to A from C, like the bottom line,
Oh, I see.
if they didn't give you the P plus Q, you would have to go the other way because you know the route. Does that make sense?
That's great. And it's a little bit also, I'm jumping onto your analogy there. So it may be that Shelby knows a shortcut to something, and so she can go that path, but you've no idea that this shortcut goes somewhere there. So you have to go all the way along Harbour Road and then back again.
So like with that, the shortcut would be AC, but the long way would be A,
Yeah.
B, C. Or
But the situation is that you only know to go this way and this way. So you can't describe to someone how to get there this way. You have to say you need to go this way and this way. So when it comes to labels, whilst this is the easiest option, you have to actually follow the paths that you've been told. So it could be that you get a diagram and they tell you that this is P and this is Q, and you have to describe those journeys just using those kinds of vectors. Okay? Now, along with that is that if you had started over here and you'd gone the exact same movement in the same direction, this would also be called P. Okay, so as long as you're going in exactly the same movement, it would be the same vector. Okay, so whilst it's not from the same start point and the same finish point, it would still be classed as the same vector. Okay, you all happy with that? Because it's going in the same direction. Yeah. Now, had we been going in the opposite direction, it would just be negative. Yeah. So if we had started at B and ended up at A, it would be negative P. Which is what I've got here. Starting at C and finishing at A would be negative Q minus P. Or negative P minus Q. Same meat different gravy. Yes, both of them are negative. Yeah. That's the answer. Now, position vectors, they sometimes start confusing people. The only tricky thing about position vectors is that they're always based at the origin, so they're always based at 0, 0. Okay? Now, if I was to consider the point P, and this is the coordinates 5, 3. So we know how to draw coordinates. We go across 5 and we go up 3. Lovely. There's our position. That's our coordinate. The position vector of that would also be 5, 3. If I were to, oh no. Let me go through this example, and this helps us a little bit better. Right, so here we go. We've got points A, B, and C. I'm going to draw a quick diagram to help me. So A is at negative 1, 2. So negative 1, 2. That's A. B is at 3, 4. So 3, 4. Oh, yeah. And then C, oh, that's B. And then C is at 4, negative 5. Okay, it's a bit of a rubbish diagram, but you get the gist of it. Now, we want to say what's the vector of B from O. So how do we describe from O, which is here, to B? Now this should be a straightforward one. So literally from, pardon? So it would be here, yeah. And how would I describe the vector? 3, 4, yeah? Nice. Now, B from A is a bit more challenging because we're starting at A. Okay, ooh. We're starting here at A. We're ending up at B, and this is where we were talking about the paths that we need to, that we have to travel the path that we know. We don't know how to get from there to there directly. So what we have to do is to go to the center. Okay, so we're going that direction and then out to B. Okay, now if we've started at A and gone back to the center, what would my vectors be? Be careful. if we're starting at A and getting to 0, we're actually going +1 and -2. Do you see that? Because it's the opposite of this. So it would be +1. Oh, why am I writing a negative sign? Fool. So we're going +1 and -2. Yeah? And then I'm going to go up to B. So then it's my 3, 4. Yeah? Have I got everyone? So, oh, this brings in adding vectors. I think I was going to do that bit next. But how do we add? Do you remember how to add vectors? You just literally add them. Okay? So 1 and 3 makes 4. -2 and 4 makes 2. So secretly, to start at A and get to B, you could have just gone across 4 and up 2. Okay? But because we didn't know that route, we didn't know that shortcut, we had to go back to it's like coming to Hamilton and coming back out again, because that's all we knew. I like your driving analogy. Thanks, Charles. All right, so now we're going from C to A. So C to A. So again, while C is secretly 4, -5, we're going to the center. So we're actually going the opposite of that.
4, 5.
Yes. So that's going to be negative. Oh, my Lord above. So it's -4, 5 plus, and where are we going to? A. And then -1, 2. I've got real itch. So that's,
You always have to go back to 0.
yes.
And I know, Shelby, I've already written back from scratch.
Yeah, it's really nothing new.
Yes, I know. And it is annoying because it's very hard to get out of the habit. Here's notes. Okay. So now, sometimes, so whilst we can use numbers like just the 2 and the 3, sometimes we use letters called I and J, and sometimes K. Now, what I and J are, they are baby little vectors that just, I has length of 1 in the X direction, J has length of 1 in the Y direction, and then if we're moving into a K situation, we're talking 3D, so the K is coming out.
Nice.
Okay?
Oh, okay.
It's totally not confusing once you get into the hang of it. So if I've got the vector from O to P, and I've gone across 5 and up 3, we would just say that that was 5i plus 3j. That's it. Okay? So it's just an I and a j, depending on the direction you've gone. So if you've gone right, it's going to be 5i. And if you've gone up, it would be 3j. So this would also be written like this.
Oh, so it means the same thing.
So you could have either of those two. And so that's just what I want to bring into, so if you see i's and j's, don't get freaked. You can just change it to be column vector if you prefer that. Okay? As I said, if we go into the 3D version, you just have k's as well. So we could have 3i plus 2j plus k. I hate drawing these things. Basically, it's out here. Adding them up, we've talked about that. You just add them. So you add the i's, add the j's, add the k's. If you prefer, you can just, as I said, change them to column vector. So vector A plus vector B, who's talking? Shush. So this would be 3, -2, plus -1, 4. Okay, so I've changed to I've changed to be from IJ into just column notation. And so that's 2, 2, or 2i plus 2j.
So it's 2i. Is I always on the top and j is on the bottom?
Yep. Okay, and then CD, so we've got 2, -1, 1, plus -1, 3, -2. So that's 1, to -1, or I plus 2j minus k. I should be underlining these. That's pretty easy, yeah? Okay, let's have a little bit of practice then. Oops.
You want to